In the previous video, we understood about PN junction, correct? What is a PN junction and how it behaves. Now, when you have a PN junction, there are two ways in which the PN junction can work. Alright, basically we call this as biasing. Okay, under biasing we have two types. One is called forward bias, another one is reverse bias. Let's understand what is forward biasing. Now, under forward biasing, look at this particular circuit. Now what you have, the P type is connected to positive, N type is connected to negative, correct? Once you have this as the circuit here, what happens in a forward bias condition? It's a very simple thing. Now when you have P type and N type, P type has more number of holes, N type has more number of electrons, correct? Now when P type is connected to positive, the holes are pushed away from the battery and electrons are pushed away from the battery. In the sense, both of them will move towards each other. Alright? What happens to the depletion layer? The depletion layer starts to reduce, or in the sense, the depletion layer decreases, the width of the depletion layer, correct? Now once that reduces or decreases, the potential barrier also decreases. They go hand in hand. So if one reduces, other also reduces. Now, potential barrier is decreasing. Now when the potential barrier reduces, there are charges on both the sides of the PN junction. In the sense, you have charges on both the sides, correct? Is in P type and N type. These two charges will start to combine together. Why? Because the depletion layer is reducing. As the thickness decreases, when the thickness is less, more charges can cross over the depletion layer. They cross and the diffusion current will start to increase. In other words, we can tell that the majority charge carriers, they are going to combine. Why do they combine? Because they are crossing over the depletion region, isn't it? Now this causes current in the circuit because charges are combining. Movement of charges is basically current, isn't it? Once the charges move, they cause a current in the circuit. That current is what we call as forward current. So this forward current is very important for a PN junction. Since many of the charges are crossing over the depletion region and combining them, the resistance of this PN junction will be very less. In other words, under forward bias condition, the resistance is very less, but the current is very high. Okay, this is what happens. Now there are certain characteristics what you have to understand under forward biasing. Characteristics in the sense what? Now we know that it's changing, the current is increasing, correct? So is it going to be exponential? Is it linear? What exactly is happening here? We say resistance is very low, isn't it? So is it going to be low everywhere? Like is it a constant resistance? Now these are what we mean by characteristics under forward biasing. For that, look at this particular circuit. You have a PN junction. The symbol what we use is the diode symbol. Okay. Now this is the symbol what we use for a PN junction. Okay. Now on the left side, the triangle side, that is the P type. And the line what you see on the right side, that is the N type. That's the PN junction. Now, it's a forward bias condition, correct? Because P type is connected to plus and N type is connected to minus. It's a forward bias condition. We have voltmeter and milliammeter. And rheostat obviously for, the obvious purpose of rheostat. What happens in this particular case? Alright, so in this what we do is that first we give one particular voltage. Let's say we are going to give 0.2 volt. Very small. Some current will pass through it and that is measured with the help of milliampere. You make a note of it. You start increasing the voltage bit by bit. 0.2, 0.3, 0.4, 0.5, like this keeps on changing. Now what we observe is that more the voltage we give, more is going to be the forward current. Okay, basically the current detected by the milliammeter is going to be more and more. Gradually keeps on increasing. After a particular voltage, the current becomes so high, this voltage is what we call as knee voltage. In the sense, for a PN junction, under forward bias condition, if the given voltage is more than the knee voltage, the current is going to become exponentially large. Look at this particular graph. This is how it looks like. Now, you see that line? It's going to be exponential, isn't it? After the knee voltage, this is how the graph is going to be. Now here, when we talk about resistance, resistance is clearly not constant. Ohm's law fails in this particular case. So what we have is dynamic resistance. In the sense, we take only a small region of the delta I and delta V, then we calculate what is the resistance. So R, the dynamic resistance R is equal to delta V by delta I. This is the formula for resistance under forward bias. Okay, now let's quickly recap what happens in forward bias. First, PN junction, P type is connected to plus, N type is connected to minus. This is forward bias. In this, depletion layer reduces, potential barrier decreases. Because of this, majority charge carriers will cross over. The current is going to be very high. And that current is called forward current, the third important point, forward current. Okay, then the next one, as you keep increasing the voltage more and more from the external battery, beyond a certain voltage, the current will be exponentially high, and that voltage is called what? Knee voltage. Okay, and the graph you have. So suppose if they ask you this in the exam, these 5 points should be mentioned. Okay, now this is forward bias. In the next one, we'll calculate and we also understand what is reverse bias.